36, I added one. So quick commercial and I get off of that. So a little over 2 years ago, Mobile Access was bought by Corning. Corning wanted to get into the wireless business, and as everybody in the room knows, they make a little bit of fiber, right? And when we look at the industry, we look at copper, and we see it going the way of the dinosaur in the near future. As you all know from the fiber to the antenna perspective initiative that's huge and it's underway, right? Corning, if they had their way, they put fiber in every bedroom, in every bathroom, in every dorm room in the United States. And maybe eventually we'll get there, I don't know. But the point is, you know, Pete, you alluded to it a little bit a few minutes ago, we're at the brink of a data tsunami here, and it is no joke. And there's good and bad that goes along with that. It's a great time to be in the business, to make a lot of money. It's a very difficult time to scale and to make it happen appropriately in partnership with the carriers, partnership with the Ciscos, the integrator communities that are out there. And everybody's talking different languages. I remember, you know, I don't know, 10 years ago, post 9/11, everybody remember the key word, interoperability. Well, Motorola had their definition, right? Nextel had their definition. Federal government had their definition. Police and fire had their definitions. But what the hell does it really mean, you know, at the end of the day? So now we're sitting here with the same problem. We got this heterogeneous network thing. Who here's heard of HetNet? 1, 2, 3. Uh-oh. Okay. Let's take a second there. I'll go back to my commercial. So it's interoperability, but it's all about taking all the different things that are available to fix coverage and capacity needs and figuring out a way to bring that all together. It could be a small cell, it could be a macro site, it could be a pico cell, it could be a base station, it could be, what else? Anything, right? And the key and the trick is here is to have a laser-like focus on leveraging all the best of breed and all the different technology platforms that are out there today and coming soon tomorrow, and figuring out how to make those interoperable. So, because the user doesn't care, you know, Pete's 19-year-old just wants his phone to work. My 16-year-old is the same thing. They don't remember when there was not an internet. They don't, right? So part of the goal this morning is to try to talk a little bit about what this HetNet thing means, what it means from a macro perspective, what it means from a distributed antenna system perspective, what are some of the pervasive technologies that we're going to see today and next year and 3 years from now, and then how does all that glue kind of fit together, and more importantly, how we in this room can work with other organizations like maybe the DAS Forum and others like that to bring common experiences together to solve the problem, because the tsunami's here, right? I mean, you got everybody, all the carriers are getting crushed. Next slide. Question. There's a Twix bar here for you. Whoever can get the closest. And no Corning answers, please. What year was Corning founded? It was before the Civil War, I mean. Any guesses?
47. 1840.
Close. I'll give you one just because. Any guesses? Come on. Wake up.
1846.
46? Now, 1851. So we're not going anywhere, I don't think. The glass that surrounded the filament for Thomas Edison was made in Corning, New York. So the glass today, there's a thing called willow glass. I don't know if you guys have seen it or not. It's bendable glass. You can literally take a strip and bend it like that. So if you can do that, you can embed smarts into that glass product, and maybe you could wear it. What does that look like for you? What does it look like for your kitchen appliance? The point of all of this is that if you look at some of these numbers up here, I highlighted some in red that I found to be particularly troubling or encouraging, depending on how you want to look at it. If you take a look at 1, 2, 3, 4, 5, annual capital investments between the last 5 years, really, between June 07, June 12, $2 billion increase. Okay, a lot of money, that's good. But look at the amount of text messages sent. Increase in the last 5 years, 2.27 trillion text messages. Now, I don't know how many sons and daughters and people there are in the United States, but I got a feeling if we did the math, it'd probably work out to about 30 text messages per waking hour per teenager. And text is actually easy. You know, what really concerns us is video. Some other interesting stats up there. Number of cell sites has not kept pace with the amount of growth we're seeing in data volume. It's just way ridiculously behind. So we have a CapEx problem, we have a density problem, and we got to have a more laser-like focus because you can't put a cell site on every street corner, as we all know in this room. So how do you attack this issue if you can't really, if you can build more macros, but not at the pace that you need to build them? Next slide, Pete. More kudos to Cisco. So they did a study, and the numbers speak for themselves. The one that sticks out at me, if you look at mobile data traffic, and I'm not the smartest guy in the room, I'm sure. When I look at something with 18 zeros in it, that's a big damn number. You know what I mean? The problem is, in the next 5 years, that number's going to go up by more than tenfold. And that's the amount of stuff that you and I and our kids and our associates and our customers are going to be sending across this network. So we got a problem. I mean, the tidal wave's coming. It's coming quick. So yeah, there's money to be made, but there's a lot of issues to be solved. We also need to increase the amount of speed. You'll see a product coming soon from us that'll start to address that particular issue. But people want their stuff and they want it now. You know, somebody makes a touchdown catch in the end zone, right? There's 80,000 people there, probably took the same damn picture, close to it, sending it at the same time, putting it up on YouTube, posting it on Facebook, sending it to their buddies, whatever it might be. How do you design for that hit, that crunch in that network at that particular moment when he catches the touchdown pass? It's bizarre to try to imagine the amount of capacity spike that you get at certain moments when certain things happen. Next slide. Bit of an eye chart, but when you start to peel back this onion a little bit more, you start to look at different ways to solve issues. And when you look at the different operators that are out there internationally, they have different tools up their sleeve, if you will. Of course, you've got the macro perspective, you've got femtocells. Anybody know what femtocells is? Femtos? So back in, what do you think, maybe 2005-ish? The first femto kind of came out, I think Samsung drove it. And I was at Nextel/Sprint at the time. And little box. All you need is IP backhaul. You can stick it in your living room and you get 5,000 square feet of coverage, which is cool, IP backhaul. And you could have maybe 3 people on it at the same time. That was the first little femto. And they're kind of neat for doctor's office deployments, somebody's cabin, vacation home, your house if you are coverage constrained. And that's a good way to do macro offload. We're seeing a lot more of those being deployed. And the capacity and the functionality of some of those femtos is increasing to allow more people to use it at the same time. So that's one way to get at the problem, is to take a dart, if you will, throw it at that house at the beach on the ocean that's not getting the coverage they need. Buy a femto. Microcells, picocells. When you look at where I come from, my core, distributed antenna systems, we've seen, I mean, the increases in the amount of business is just absolutely ridiculous. We've gone from a place where people want to solve for bars on phones, the VP wants his BlackBerry to work from 5-6 years ago, to I think we're at a place right now where in the distributed antenna systems business, not only do we want to solve for coverage and capacity, right, but we want to also provide a baseline for which you can do things with that coverage and capacity. Because there needs to be some sort of return to that particular customer on, why should AT&T spend all this money to build a multi-million-dollar distributed antenna system at Ravens Stadium in Baltimore, or a college, or wherever it might be? And why should the university spend money on a DAS system just to make a phone work? Well, there's a lot of pressure to do that, but when you start to be able to hang applications off of that, like I'll give you an example, Disney, they've got a card right now that they're using, and they're moving to an electronic bracelet. It's called KeyChest. So when you enter the park, what you do, where you go, what you buy, fast pass, your hotel, the beer, whatever it is on the card. You're captured because you have Wi-Fi and cellular RF coverage throughout 5 parks in Orlando. A stadium, for example. Why couldn't Aramark offer 20% off of hats in the 7th inning if you subscribe, if you're a member of Red Sox Nation, if you will? You opt in with your smartphone. In a hotel scenario, why can't you have a smart hotel room? Not real keen on our smart hotel rooms here, especially $11.95 a day for Wi-Fi per device, but anyway, that's a whole other item. But it's one of the biggest dissatisfiers in the hospitality industry is lack of intelligence when we travel. We all here travel quite a bit. And there's nothing more frustrating to me than having bad connectivity or lack thereof, because we got to get our jobs done. So, next slide, Pete. Build it out, if you would. So we got a data tsunami. We've got new technologies. We're moving to 4G, which has taken the brunt of a lot of new capacity requirements, and that's a whole different animal in terms of how to design for and leverage that particular technology. There's new spectrum coming, and then you've got all these indoor networks that are out there trying to supplement the macro, because the macro just cannot handle the capacity constraints, particularly in large suburban and urban areas. So we have these issues that are causing problems in the industry, but there are ways to start to fix them. Go ahead, Pete. Okay, so what is a small cell? You guys can read it. Pete talked to it a little bit. So really, the analogy that I was using, I think it was last night at dinner, and I don't know how good it is, but I'll try it on you guys real quick. So if you build a macro, metal pyramid, and it has a circular array of coverage in a suburban area or an urban area, and if you were to kind of take a dartboard and lay it on the ground, it would make a round circle, right? And then there's certain areas that macro will penetrate better than others based on shadowing, buildings, wherever it might be, right? So what you can do with a small cell inside that dartboard that's laying on the ground underneath the coverage umbrella, the cell site, is you can just take a dart and throw it at, I don't know, the number I used was 1818s. Because if 1818s is where you got your problem and where you need additional capacity or you need a little boost in RF, and maybe it's the entrance to the student union at Indiana University, then that's where you throw your small cell up to complement the macro to get a little extra bump in capacity and coverage there. So again, back to HETNet, heterogeneous networks, is how do these different technologies start to complement each other, right? Next slide. Typically, we'll see these things deployed in a couple different ways. One will be enterprise, operator deployed, consumer and enterprise deployed, meaning the customer's going to put them in, Johnny's going to put it in his vacation cottage at the beach, or AT&T is going to put it in, integrated into their network. And they'll have priorities and lists. There'll be hot spots, maybe spots that aren't so hot. And that'll be up to, Neil can speak to that a little bit more about how that actually works from a carrier perspective. But we see two ways that these things will be rolled out. And we see these technologies as complementary, not contrary to each other. Because at the end of the day, remember, everything's got to work together. So when you do the algorithms and you tune your network from a carrier perspective, you get the right customer experience. Next slide, Pete. So there's some barriers out there that we all have to deal with. When I look at small cell, I'm thinking, okay, so the small cells today is a metal box about that big, and you can mount it, and it's $5,000, and it can do 1,000 square feet, roughly. And so that's nice. And you can throw the dart in 1818. But now you have, as soon as the landlord finds out, then they're going to want a little bit of this, right? And then you got some backhaul issues. So where the jury's at least from my perspective, and I don't really understand, is what's the 5-year cost and return on that small cell from a carrier perspective? Because it's not just the $5,000. It is the monthly recurring that's going to happen here during this process. So there'll be barriers there, and then integrating that in, finding your backhaul connections on campus in the bowels of New York City. You know, it's not as easy as just putting it on a wall and flipping the light switch. Next slide, Pete. Blow past that one if you would. All right, this is probably the worst eye chart you'll see all day. Who's familiar with distributed antenna systems at any level? Good. Okay. So what happens here is it doesn't have to be pointing mobile access. It could be maybe a little closer. The thunder cells, small cells, the base station, the remote radio heads, whatever it is. Okay, it's kind of like a little network back in that IT universe. The thing that's going to change here in this business is you're going to introduce a lot more of this yellow stack, this private cable. What that's going to do, at least we think, is it's going to allow us as an industry and Corning as a company to deliver a hell of a lot faster stuff after that antenna, so that you can do a lot more with it for about the same price. So there'll be a slow migration from coax in the horizontal to fiber in the horizontal. So your endpoint will be smart. You'll have gigabit Ethernet. You'll have a multi-carrier solution, soon to come public safety. So if you can separate the fiber and say, okay, this is for Wi-Fi, this is for cellular, here's my pod, there's the ceiling, flip it, commission it. Now you got some fast stuff out there. If you can actually hard plug in, let's say maybe a IP surveillance camera into this pod, or maybe enable asset tracking for the customer, or maybe the client might be interested in some sort of safety and security application because it's a college campus. I don't know about you guys, but I've had kids in college and like my daughters to be safe. Now that end user enterprise client and the carrier and us as consumers are starting to realize some utility out of this distributed antenna system, and it's not just about making bars on phones work. It starts to change the paradigm. So in this foundation, what we intend to build is fiber in the vertical and fiber in the horizontal, and really kind of build the foundation for the house. And then the question then becomes, to our carrier partners, to the end user communities, to our integrator communities, and to our distributors, we will do it. There it is. It addresses the issue. You can plug stuff into it in a heterogeneous kind of way. The question to Marriott would be is how can I help you make a smart experience for your clients and improve the utility for your back office staff? What does it look like? Different question than saying, oh, the BlackBerry works. So, follow me? Next slide, Pete. Build that one out. So we see some things coming past the first wave of this, but again, the fundamental foundation of all of this stuff to enable small cells in a campus type environment or a skyscraper / hotel, hospital type of environment, the common element here needs to be you need to have a fast pipe. You got to get to composite cable so you can power those end units so that unit can do something. You got to reduce size and space requirements inside the enterprise itself. So with that, that's what we're trying to do. So at the end of the day, you can bolt things onto that foundation that we built, add your bedrooms as you like it, if you will, to build your own house, and plug in the RF sources as you see fit. It ties back to the macro network and ties to the small cell and the femto cells and whatever is out there that's supporting that so that the carrier can then optimize that network so it all sings the same song. Next slide, Pete. Build through that one as well, if you will. That's redundant. So, drinking out of a fire hose. So pause for a second. Comments, questions? Where do you see this from y'all's perspective? What do you think? I might have to start throwing candy here in a minute, right, Frank? All right, well, thanks for your time. I appreciate it.